Hello, welcome back. In today's video, we will discuss about Web- WebSocket APIs. WebSocket APIs support two-way connections. That is, both the users and the backend can send messages back and forth once connected. So it is used in real-time applications like charts, broadcast messages, or real-time dashboards. You can create WebSocket APIs in AWS using AWS API Gateway Services. The sample use case that we are going to see today is a real-time application. There are few components here. First is obviously the API Gateway service itself, which is used to set up the application, and that is connected to three different lambdas to perform three different actions: to establish connection, to send message, and finally to disconnect. Then we have DynamoDB table, which keeps track of all the current connections. Now let's get into the AWS console and let's get started by creating DynamoDB table. Click on create table and we are going to call the table name as WebSocket connections. and and this is going to be used to store all the active connections, and we're gonna just now gonna store the connection ID, so that's going to be our partition key. And these connection IDs are auto generated values which are generated by API gate. Now let's create the table and let us wait until it's created. Now let's get into Lambda console and start creating our three lambdas. So let's create a function. So the first lambda function is going to be WebSocket connection, and this is going to be invoked whenever there is a new connection in our API gateway. And I'm going to use Python 3.9, that's the latest version supported by Lambda. And let's create the function. So the WebSocket connection is successfully created. Now let's get into our code of WebSocket Connect. So this is going to use the boot3 library. I'm going to put it in DynamoDB with connection ID and deploy this. Now we are going to do two more things. Let's head over into configuration and environmental variables. Now we are going to create an environment variable to store DynamoDB table name. Our key name will be WebSocket table. And the value will be WebSocket connection. So we are gonna save our environmental variables. So the second thing we are going to do is permissions. So you're gonna set up some lambda role permission in order to for it to be able to put it in Dynamo table. Click on the policy name, permissions policies. So whenever we create a lambda function, it automatically comes with a default role which allows to add CloudWatch logs, and we are going to now add DynamoDB permissions as well. Let's add more permissions. And name it as DynamoDB. And let's allow actions allowed will be put item, resources will be left same. You gotta add a specific ARNs. The region will be US East, and as well as the table name. So the ARN of the DynamoDB and action will be allowed to put item. And add ARNs. Because that only action we need for particular dynamo. Now let's save the changes. So we are done with our first lambda. We are gonna say to follow the same steps and create two more lambdas. The second one is going to be WebSocket disconnect. Let's go to our lambda and create a new lambda called WebSocket disconnect. So this will be invoked whenever there is a disconnection request to the WebSocket API. So again we are going to use Python 3.9 and create the function. Now the WebSocket is disconnect has been created. Now for this particular lambda is going to invoke DynamoDB again, but it will be delete data. So we are going to delete the connection ID that's been disconnected. So this is the code, we'll deploy it. Permissions, we'll change the environment variables. We're gonna add environment variable. Key will be the table name, lambda socket underscore table. Our value will be WebSocket connections. Now let's go to the permissions. We'll update the permissions. So under execution role, policies.
So it is very important to have limited permissions to your lambda so that you are well aware that what your lambda can and cannot do. So we're going to add DynamoDB as a service again. Delete item, that is the action for this lambda that can handle. And we're gonna add the specific ARNs, the time region, and the table name. Let's add our ARN. So let's save the changes. So we are done with our second lambda as well. Now moving on to our third and final lambda. That's going to be the main one. Let's create the third and final lambda again. The name of this will be WebSocket send and Python 3.9. This is going to be our main one, which is going to send the messages. We are going to call it as WebSocket send. Let's create the function and let's scroll down. This is going to do the scan of DynamoDB and get all connections ID, and also get going the API gateway and API endpoint, so the end URLs can be derived from the event message. Now let's go to the environment variable and edit the table name as the key WebSocket underscore table, and WebSocket connections as the value. And now we are going to update the permissions. The role name WebSocket send role. Permission policies. So here we need two different permissions. Usually we need DynamoDB permission, but this time it's going to be a scan also. So in the policy, let's choose DynamoDB as service. Under action, let's choose be scan and specify the table. Let's type in our region and table name. WebSocket connections. Add ARN. We are going to add one more permission. that will known as execute API. Now we are going to allow the action called as managed connections. So this will allow the Lambda to post messages into the connections. I'm selecting the API gateways within the account because we haven't created any API yet. So we can come back and edit when we have into the actual data. Alright, we have all the three lambdas, and the last thing will be creating the API gateway.
Okay, let's get into our API Gateway console. In this case, we'll be using WebSocket API. We will give our API name as WebSocket API, name as WebSocket API, and we'll give a root selection expression request.body as action. So this API, so this is how your API will know that which route is to redirect your request to. So you have to mention the route name with the action only. So we are gonna have three route different routes today. One is for connect, disconnect, and one is custom route named as send message. So the send message is going to be a custom route. So you can also opt for a specified route. So if your action doesn't match any action routes, then it will redirect the default route. So we have added send message. We're gonna go to next. Add our attach interrogation integrations as type lambda. First one will be connect. Second will be again lambda, and lambda function will be disconnect. Integration for message will be lambda and lambda send function. We're gonna add stage name demo as demo, and we will finally review all the details we have entered, cross check everything, stage name demo, and create and deploy. Let's wait until its APIs get created. We'll deploy the API. We will keep a stage name called demo and deploy. So we have our API running. So let's get into stages. If you can even have multiple stages for the same, our API gateway and here copy the WebSocket URL and let's see how that works. So I am using Postman over here. Here you can use either Postman or any other AWS clients that you prefer. Now I'm going to create a WebSocket and copy the URL link over here and connect it using it. As you can see, it's connected. I'm going to create one more WebSocket connection using the same URL and connect it and create one more to So as you can see, now I have created three different connections now. Let's get into DynamoDB and see if there are three different entities. So let's go into WebSocket connection table and explore table items and refresh. So as you can see, there are three different entries in there. So I will try to send a message using the postman using the WebSocket. So our first connection. So the message body should have something called action. So this is the root name which we mentioned while creating an API gateway. If you remember, so action should match the exact root name. So then you have a specific message itself. So I'm trying to send hello from terminal 1. So let's assume that this is terminal 1 and terminal 2 and terminal 0. So there are three terminals. So I have sent hello from terminal 1 and received in the log. And you can see that it's been also received in terminal 2 and also received in terminal 3 also. So I'm gonna send the same message in terminal 2 and check again. So I have sent it. So you can see it's been sent from terminal 2 and received the message from one and third terminals also. So as you can see, these all terminals they are interconnected. So you can send a message from terminal 2 and they will be received by terminal 1 and 3. So that you have an additional attributes here and they play around and send specific terminals or specific connections. And you can restrict from being able to send different connections. You have various options and have disconnect one of the two connections over here. And I have gone back to DynamoDB and see you can see that when the other two are connected and the other two are disconnected, I can only see one of the connections remaining. So right, it's so simple. So this is one of the use cases with API gateway WebSockets. You can do various other cases like this while setting up a real-time dashboard and also a real-time operations. Thank you for watching my video.